Appreciate the words, Dr. Napper. I'm glad to be here. Glad to be talking to you about philosophical and ethical issues in science. Over the last, I don't know, 5 or 6 or 7 years, this area has acquired an increasing, it's generated an increasing interest. When you go to graduate school, when you find yourself working in industry, you find yourself as a practitioner in science and engineering confronting these questions with a greater frequency. There's now, in graduate school, for example, in Shreveport at LSU, there's now a formal course dealing with these issues. These are the sort of thing that you traditionally didn't see, problems you didn't confront until you were out there in the real world. That is to say, working in science or engineering, whether it was after a BS or after a graduate degree. But they, and you still don't see very much of a discussion about these points now as an undergraduate. But you're going to find that these are important issues that will confront you in the workplace, and they're certainly going to confront you as graduate students. I'm going to touch on the most important aspects of them. I'm giving you kind of the high points of 3 separate areas when this course is taught as a graduate course in Shreveport. One area has to do with data sharing, one has to do with the use of animals, and one has to do with human experimentation. I'm going to hit what I think are the things you need to know about. You need to at least have been generally apprised of before you go out and confront them for the first time. Can we turn the lights down a little bit? Is that possible to do that in here? One of the things I'm not doing is by ethics and philosophical issues. I don't want to sound too ethereal. I'm not going to be talking about Paul's letter to the Thessalonians or the book of Exodus or something. I mean, I'm talking about stuff that lays just in front of you if you haven't confronted already. There are 4, I don't know, the threads or aspects of the points I'm going to make, and I want to bring them clearly out now, because the different topics have an admixture of one or more of these notions in different proportions. But all the topics I'll talk about go in and out of these various factors. The first notion is that of a pure sort of ethical issue. It's something that might have a lot to do with how you were raised and how you look at life. There are issues like this in science. They mostly tend to be at the cutting end of what's being done. One of the examples I'll talk about at the end, if I get to it, is the question of fetal tissue. Fetal tissue used in research, should it be used, under what conditions? The jury is still out on whether that's appropriate and the conditions under which it's going to be done. That's what I mean by philosophy having some impact on the thoughts or the notions in this area. The second thread deals with what I call scientific issues. If you're working for a drug company and the task is to find out whether or not a particular drug is efficacious for a particular disease, you don't have a lot of flexibility about how you're going to do that. I mean, your own personal ethics don't really matter very much, because there are clear rules about how one goes about making a scientific proof that such and such a drug is effective for such and such a disease. So here we're talking about, we're dealing with human beings, we're taking data with human beings, but we're not dealing with pure ethical issues, because the rules for how those studies are to be done are pretty well crystallized. Another thread involves what I call binding procedures. If you're in an institution and you're going to use rats in a study, how you're to use rats, how you're to handle them, the number of animals you're going to be permitted to use are all independent of your personal philosophical and ethical considerations. There are rules at the institution where you're going to be functioning, and you're going to follow those rules and use animals under or pursuant to those rules, or you won't be using animals. So the use of animals, as we will see, involve philosophical and ethical issues, but the core notion is an emphasis on following rules, identifying rules and following rules, not being blithely ignorant of them. and following them, as opposed to sort of making up your own mind about what's appropriate to do. The last issue, an important one, has to do with how a scientist ought to function vis-a-vis other scientists. We're going to see this in some detail when it comes to a consideration of data. When you adduce, acquire data, how do you handle it? What are your responsibilities for disclosing it, making it available to other people, other folks who are collecting data? Before I start talking about data, I want to make it clear that I'm talking about science and philosophy and ethics of science. I don't necessarily have to have you define for me or explain overtly exactly what science is, but what do you think? What do you think science? What would you say is a distinguishing characteristic of science as compared to other human activities? What makes? I mean, all the stuff I'm talking about has to do with science. What is science as opposed to non-science? What distinguishes it? Anybody have any idea? You all seen? Yeah.
It seems to go towards learning something that's not known.
Doesn't the historian do that? Doesn't the sociologist do that? Don't a lot of folks look for knowledge? I mean, knowledge and science aren't synonymous, right? You can have knowledge in a whole bunch of other areas besides science. So we need something more than that.
Science revolves more on the scientific method of direct observation and instrumentation.
That's true. Direct observation, instrumentation, offering theories, offering reasons, providing mechanisms. But other non-scientists do that. You know, historians do that. They observe patterns, they observe group behaviors, and they build models. Economists do that. They build mathematical models about and they're going to predict whether you're going to buy a Nissan in the year 2002. So, so the scientific method that you're coming to grips with applies to more than just engineering and physics and chemistry. So, that's close, but is it really the defining characteristic between science and non-science? Any other? Well, in principle, at least this is my answer to the question, and I think it's important because it takes us down one road versus another. The defining characteristic of science for me is an attempt to explain things on the basis of observations that are devoid, or more practically, minimize our own value system. Science is supposed to proceed on the basis of observations, as was pointed out, but it's not supposed to incorporate individual values. I mean, that's what ethics is for. That's what religion is for. That's what law is for. So it's an area of human endeavor, and near as I can tell, the only one where we make a conscious attempt to downplay the personal value judgments and elevate what we observe about nature. We treat nature as this objective entity out there. We imagine ourselves as passive observers of it, and the name of the game is to provide a good description of what takes place, independent of our own subjective state. That's what makes science, in my mind, different than virtually every other human activity. Many of the problems that we're going to discuss today, and problems you're going to see with regard to this general area of philosophy and ethics of science, have to do with the human weakness, or the human beings being human beings and being unable to implement that fully. In principle, our observations are supposed to be independent of our values. How we handle data is supposed to be independent of our values. But in practice, it turns out to be just a darn hard thing to do. Ownership of research data is a good example of that. I want to focus on the real heart of what a scientist does. I mean, a scientist generates data. That's the product. And you don't make a car. You don't. Even an engineer. The product of the engineer is a prescription on how to make some optimal solution within this a framework of certain limitations. That's really what the product is. I mean, the guy who goes and does it functions at a slightly lower level than that. He's got a cookbook to follow. The creative part comes in solving the problem within the limitations that are provided. So what is he doing? He's generating data. The graduate student is certainly generating data. The faculty member in your department who's doing research is certainly generating data. Who owns that data? Who does it belong to? If Dr. Napper goes into the laboratory and makes some measurements and makes some observations, does he own the data? And he works for this institution. Is it his data? Does it belong to him? Can he do with it as he pleases? The question is important because whoever owns the data is going to decide what happens to it. That individual is going to decide, first of all, whether it's published or not, and if there's money to be made, he's the one who's going to make the money because it's his data. So the ownership is not a trivial question. It's a fundamental question. It's going to be the dominant question, directly or indirectly, for the rest of your careers if you stay in science. There'll be a slight deferring for 5 years while you're a graduate student. The question won't be so immediate. It certainly will be after that. I mean, when Dr. Napper does science, it's certainly an important question to him, what happens to the data. The model I'm going to be talking about is the academic model, the graduate student, the professor, and much of what I'll say, the points I'll make, I mean, you're going to have to translate it in your own mind to the situation involving an engineer, for example, functioning in industry. The concepts will apply in a direct way, as you'll be able to see. The academic model has a few more degrees of freedom, and hence worth talking about. I wanted to give you some feel for why this is important. The United States government spends about, of all its R&D funding, about 15% of it is spent for health-related biomedical concerns, very broadly speaking. 15% of its R&D dollars. Now, how many of those dollars are there? Well, it's outlined here in blue. In 1960, there were less than $1 billion of those dollars, and this blue curve indicates the growth of federal spending in this biomedical area since 1960. As of last year or the year before, is around $12 billion. A lot of money used to generate data, used to generate information, which in this information age is power. It's everything. The red line indicates the number of dollars spent in this biomedical area by industry. It's now almost at $16 billion. It passed Uncle Sam in terms of net dollars in the late 80s, and the gap, I think, is still widening. So what? This is the information age. Knowledge is everything. The federal dollars generate knowledge which, with certain limitations and exclusions, which I won't go into, is generally available. I mean, if you need it or you want it, you can get it. Why? Because your tax dollars paid for it. All of the knowledge generated by those dollars, however, belongs to who? Belongs to the company who generated the knowledge. There's a fundamental change in our society. It's ongoing right now. It's the flip side of recognizing explicitly that we do live in the information age. Information is power, so the folks who have the power are the ones that have the folks that have the information are the folks that have the power and best able to deal with what's coming in the future. Increasingly, that knowledge is out of the public domain, is in a private domain. So the information generated by the dollars outlined in red will pass into general use only when there's a perception that it's the dollars to be made from it, the profit to be made from it, is over or minimized or lost or not available. It's really quite a different way with regard to generating the knowledge that our society functions under. The basic answer to the question that I posed about who owns Dr. Napper's data and knowledge is what? Who owns it? Who would you say owns? His work came out of his mind. He designed the experiments. He collected the data. Who owns the data? He works for Louisiana Tech. Who owns the data? Louisiana Tech. Louisiana Tech, that's right. It's obviously clear, isn't it, if you're working for industry? It's obviously clear. Louisiana Tech Works owns it because there's this general provision in American law, and it's so general it's hardly ever mentioned in an academic setting. It's called the work for hire doctrine. You're working for somebody, you generate knowledge within the context of that employment. It's the people who pay your salary that own the data. Now, all of us in academia are used to deciding what to do with the information. We'll go ahead and publish it. In fact, if we don't publish it, we don't get promoted. It's not only a question of deciding to publish it. We have to publish it in order to make academic progress. But that only applies to data that has no financial implications. At our institution, I presume here, before somebody who has generated data is able to go ahead and publish the data and disclose the data, if there's any potential financial value associated with it, it's got to be disclosed to the employer, the organization, in my case LSU. They then decide whether they are going to retain the data so that they can perfect a patent. That's the system that we all function under now. It's called technology transfer. That's the fancy name for it within the academic setting. Within an industrial setting, there's never any question about it. If you're working for company X, you're doing some activity, you're designing some process. If it has certain patent capabilities, then what you're expected to do, since you're the inventor, you'll be listed on the patent application. That's what the law says. But all the rights to it are assigned to your employer. So the academic tradition is to go ahead and publish. But each faculty member has got to make a decision about whether or not there's some potential issue of money to be made from the product being the data. Yeah.
May we ask questions?
Sure, please.
Okay. Question though, if the institution that you work for is not willing to pay the patent fees, but you are willing to pay the patent fees, then don't you deserve the rights to that patent?
You don't deserve the rights to the patent. The reason is that the rights belong to the employer. So the question really is, will your employer deign to assign you those rights? If the employer decides not to do it, then the patent rights go nowhere. On one hand, the information and its implications belong to the employer. On the other hand, the employer has decided not to go forward with it. You know, if you own something, you don't have to use it. I mean, part of ownership is the right not to use something. So your employer does not have to go forward with it. If you're working for the General Electric company and you come up with a crackerjack design for a new transformer, the company may or may not decide to seek a patent on that invention. If they don't, it doesn't mean that the transformer design belongs to you. It still belongs to them. The right not to do something is theirs. And in fact, what's happened over the last few years is more of a tendency to not assign. Classic example, Provazic. Do any of you remember the movie The Fugitive? What's his name? Yeah, Harrison Ford. I don't know if you remember the plot underneath it. The guy's on the lam because they're after him for killing his wife. But the plot underneath it is that there is an investigator who's doing a clinical study testing a new drug. And the drug is designed to treat a certain disease. But what's really happening is this drug has got terrible side effects and it's killing people. And the manifestation of the side effect shows up as a pathological change in the liver of the people who die. And the bad guy, the protagonist, the guy who's developing Provazic, is trying to hide the fact that this drug's got side effects. If you're next of kin to somebody who took the drug and died, and you bring a wrongful death suit, who are you going to sue? Are you going to sue the guy who's doing the study? You're going to sue the institution that he works for. They're the ones that have the deep pocket. If Dr. Napper generates data, and that data is put out into the public arena, and somebody is hurt by that data, then the people who are going to be sued are not Dr. Napper. I mean, he doesn't have the kind of money they want. The state of Louisiana does. Now, it turns out that companies, that the state of Louisiana is going to be less likely to give you rights to your data that you've generated because even though they make the assignment, the law is that they still remain vicariously liable. So that if it is yours, you do develop it, and it does wind up killing people because it poisons their liver or whatever, the state of Louisiana is still going to get sued.
Does the state of Louisiana not have a disclaimer?
Yeah, but it's not effective. You know, the law does not allow you to just disclaim responsibility in certain situations, no matter how many signs you post. And this is one example. I'm not at all sure that it's going to wind up being this way on a permanent basis, but that's the way it is now. So if you're an investigator, you're a faculty member at a state institution, you have to hope that, and you do have something that you believe is patentable, you have to hope that the state goes along and gets on board and pays for the lawyer and backs it. Because they are not, under the present environment, likely to make an assignment of those rights. They used to, 6 years ago. I was in exactly that situation, and the state assigned me the rights for an invention. 6 years later, I'm asking for the rights, and they're saying no for another invention.
So what happens if the state or the employer does not decide to seek a patent? Could you then go to another company, another employer, reproduce the data, and then seek another patent for yourself?
Well, okay, that's a good question. What do you think the answer is? What's your opinion?
Well, there's no patent on it.
Go ahead.
You're not supposed to repeat or disclose those results of the experiment.
Yeah, you know, isn't that the same thing as when you buy a computer program and you say, well, I bought this program, it's my program, so I'll make a copy of it, and I'm going to have a second, and I'm going to have a third copy and a fourth copy. You know that's illegal, you can't do that. It'll be the same thing. I mean, the law is not going to let you, it's going to consider that to be not the adducing of new data, but producing data under fraudulent circumstances. I mean, you're not doing science anymore. You know what the result is. You've already done it. You're just using a Xerox machine. They're not going to let you do that.
But if you already gave them the choice, and they denied the choice.
Ah, but here's the point. The data belongs to them. And if you have a car, and I come along and say, just use your car sitting in your driveway, and you're not using it, so I want to use it. You say, well, geez, it's my car. I say, but you're not using it. You say it doesn't matter. The concept of ownership includes the right not to use something. They have the right not to use their data, yeah.
But I thought the purpose of the patent was to keep other companies from using your data for a set amount of time.
Ah.
However, if you do not have a patent, how do you claim the rights to it?
I'll tell you what a patent is in a few minutes, but that's not what a patent is. A patent is the government grant to you a right to prevent somebody else from doing something. It doesn't give you any rights directly to do something. It just gives you the right to prohibit somebody else from doing something. That's what a patent is. In this case, we're presuming that this data relates to something that is directly patentable. I'm not talking about whether or not it is patentable. I'm going to assume it is. I'm asking who owns the data. And the answer is the employer owns the data, whether the employer chooses to use it or not. Can't you see in an industrial setting, wouldn't it be very clear? I mean, if you went to General Electric, go back to my transformer example. In an industrial setting, if you had a design and build a better transformer, and GE decided not to patent it, not to go forward with it, do you think that you would then be able to go someplace else and deny, essentially remove the data from GE and use it someplace else? Does that? You wouldn't.
Say Dr. Albert quit Tech, did not want to patent, so he quit Tech, went to work for another university, did all the research again. Where do they draw the line that, well, the knowledge you got or received prior was from Tech? I mean, they don't have the rights on Dr. Napper.
No,
He can go from university to university, but how do they work the knowledge that you received from one university? Is that just?
We have from a conceptual point of view, a very simple issue conceptually. I'm going to ask factually. Is the data he generated the second time the same as, or is it independent of what he did the first time? That's all. Now, if you tell me it's essentially the same, then I say, then he's essentially stealing somebody else's property. If you tell me it's different, then it's a whole new ball game and the prior experience doesn't matter. So conceptually, it's very simple. Now, as a matter of proof, proving one or the other, that can get complicated. But we're not talking about a matter of proof here. We're talking about this issue at a conceptual level. And at a conceptual level, it's very simple. Just like a tort law. Conceptually, if you act in an unreasonable way towards somebody else and that person is injured, you're liable. Well, what's unreasonable? Ah, that's why we have the trial. That's a matter of fact. At the conceptual level, it's very clear. And what I gave you is just the entire law of tort in one sentence.
Another little twist. Okay. Say you have a federal grant to conduct the research. So you get outside funding, but yet the research being conducted at this institution, but the money's coming from another source, and there's an invention involved. Who has the rights to it?
Good question. Almost exactly the same answer. When you get a federal grant, if Dr. Napa gets a grant from NIH, the grant isn't to Dr. The grant I have from NIH.
You never bought a can of formula with the federal grant.
Say again?
Maybe never bought a can of baby formula.
All right. The grant, I have a grant from NIH. The grant I have from NIH is not to me. We speak as if it's to us. I mean, I wrote it. I'm the one who sweated it out. I'm the one who went back to the study section and argued with them about this or that. I'm the one who paid my dues, and I got the money, right? It's my grant. No. Every grant from NIH, every grant from NSF goes to the institution. It doesn't go to the individual. Part of the, and if you ever look at the boilerplate, if you're an investigator, and you ever look at the boilerplate that's behind the grant, what you see is the institution has legal title to the equipment, the institution's rules for hiring and firing govern. You're only the brains. You have no legal rights to the data that is being generated by that grant because of that grant. NIH may reserve some rights. Whatever rights they don't reserve, your employer gets the rest. You get zip. It makes no change whatsoever at the level of the investigator where the money comes from. The only thing it affects is the relative position of the grantor and the institution that the principal investigator works for. That's all it affects.
Okay, what if you develop something on your own time, not the company's time, and if that something is totally independent of your work and the company, then what is the case?
What do you think? What would you say? I mean, you know, keep in mind, what is the basis for Louisiana Tech owning Dr. Napper's information? What is the basis for that? Right. And you're hypothetical? You're not working for them. The data you're generating is not directly or indirectly a term of your employment contract. You're your own man.
Okay, what about if the device that you developed is somehow has something to do with your work?
We're back to question of fact. We have no conceptual. It's either substantially developed within the framework of your responsibilities at work, or it's not substantially developed within the framework of your responsibilities at work. It can't be both. It's going to have to be one or the other, and that's why we're going to have the trial, if it God forbid comes to that.
Let's say somebody's working in an institution like Louisiana Tech. You have a project. You got federal, state, and even private contributions coming in.
You're talking about an individual investigator? Yes.
Now, who would have the rights to the patent?
Same answer. Who would have the rights to the patent? The answer would be the same with regard to the principal investigator. I have contract money, I have state money, and I have federal money. That does not change the issue about who owns the data I generate. It's owned by some combination of my grantors in the state. None of that changes vis-a-vis me. Now, the legal question of what about among them is another matter. I mean, that's a matter of contract. We don't want to get into that. The point I'm making is that as the individual, as the investigator, as the faculty member, as the employee, this information does not belong to you. This is an information age, and this knowledge is. I paid not too long ago $16,000 for a tape. A quarter-inch videotape. It's in a box this big, $16,000. And the tape itself is worth about $3. The other $15,997 went for the code that was on the tape. That's the world's premier image analysis program. I paid for that knowledge. And you're going to find yourself in that position throughout your career. That is to say, either generating knowledge, paying for knowledge, or using knowledge is how you're likely to spend a lot of your time functioning in the future. I mean, you're on that kind of a pathway with the kind of education that you're getting.
What if the person who is getting a grant moves to a different state?
It's a variant of the same question, and the answer is exactly the same. All it changes, we went from a two-body problem, which was the investigator and his institution, to a 3-body problem, which is investigator, institution, and NIH, to a 5-body problem, investigator, institution, NIH, and 2 other grantees. Now we have a 6-body problem, another institution. The answer is still the same. The apportioning the rights among all of the non-investigator entities can get complicated. It does not change. It does not give the individual investigator a greater hold ethically, legally, morally on his data. It doesn't make any difference how many cars he has in his driveway. I still don't have a right to go use one of them. The folks who may have different interests in the cars may fight among themselves. It does not directly bear on my rights. I guess I went a long way toward trying to emphasize for you why how these ethical questions develop into practical questions. We had a bunch of examples in the context of an investigator working for an institution, but let me present some other fact patterns, all of which have occurred. I mean, I've seen and been involved in all these kinds of things. They all happen, and they relate to data. They relate to data and how it's to be used and who's to get it and what's the right thing to do. It's an important consideration, but outside of this academic model I was talking about. And I don't want you to think, my point now is to convince you that it's not just only in the context of this academic model that this issue arises. Within a purely scientific area, one way it arises a whole bunch is when, and also put aside the question of the money and who owns it, and just sort of look at the ethical issue involved here. What's the right thing to do, in other words? It would not at all be unusual for somebody who goes to graduate school to develop an animal model. It develops a mouse model where this mouse has a certain propensity to gain weight, and it's a great model to test obesity drugs. Or an animal has a propensity to develop cancer, a great model to test drugs having to do anti-cancer drugs. Or he develops an antibody that's incredibly useful for defining the location of a certain protein in a cell. So it makes a great reagent for doing immunostaining procedures. And you might do this as part of a PhD thesis. I mean, a classic thing would be to develop some sort of a reagent, an antibody, a mutant gene, and then after you've developed it, as a graduate student, you go ahead and use it to measure something, and now you write a paper and you tell the world about this reagent that you've developed and how useful it is. And what is your intention to do next? Your intention is now you want to go into academic research. You're going to use this data in order to get your first NIH grant. And you've already paid your dues to develop this reagent. It's a very powerful thing. It's very useful. No one else has done it. Now you're in a position to tackle some problems that couldn't be tackled before because nobody else had this antibody or this reagent. So you're going to write to NIH and ask for some money to go ahead and do that experiment, and you're going to need that grant in order to make your way up in the firmament of academia. But now Dr. Jones, who runs the big lab at MIT in biology, wants some of this reagent so he can do his experiments with it. It's a terrible conundrum for a young graduate student just graduated. If he gives it to Dr. Jones, who has a lab factory, I mean, he's got 5 graduate students and 5 postdocs, and he can milk this reagent for everything it's worth just like that. Whereas a young guy just starting out, just finishing his PhD, trying to be competitive, what he really has to sell, the thing that makes him competitive at the next level is this specialized chemical. On one hand, the traditional strictures of science say that this is knowledge that's been generated. It ought to be available to everybody. On the other hand, it's like cutting your own throat professionally. It's a serious problem that can develop for people in certain areas of research. Legal issues. Is an investigator who does a study and finds that kids who live beside power lines are more likely to get cancer than kids who don't live beside power lines. Now, 2 people unrelated to her are involved in a lawsuit. Smith is suing the XYZ power company because Smith's son got cancer and they live beside a power line. And what does Smith want? She wants the data from the study that's been published in the literature that describes the association between kids who live beside power lines and the likelihood of getting cancer. Now, does the investigator of that study have the responsibility to disclose? It's not just the peer-reviewed publication, that's out. Does she have to disclose? In a law case, you see, you're just not going to deal very often just with what's published in the peer-reviewed literature. The experts are going to go after the fundamental data because they're going to be trying to shoot down the other guy's expert. Now, does this scientist who is unrelated to the lawsuit have an ethical responsibility to go over all that raw data? What's going to happen is it's going to be published in the press. People are going to misquote it. She's going to be drawn into this controversy, whether she likes it or not. What's the right thing to do in a situation like that with that data? What should she do? What would you do?
Would it be, if you firmly believe that what you published is true, and you have the choice, you personally have the choice to give that data to that person or give it or not to.
Right.
How can you not give it to that person and say you fully believe in what you published?
All right. Suppose I told you that after this data was made available, now there are tables of numbers. Okay, there are observations that are written down. That's what this raw data is. You're going to now be subpoenaed to testify about what you wrote. One side is going to want to make it clear that in fact these numbers show that it was an increase in risk for cancer was increased by this amount, and this other side is going to be trying to show that you're just about the lousiest scientist God ever made. I mean, you really stink. You just did this terribly wrong. They're going to be doing everything they can to undercut your credibility. Now you're a fact witness. You're not testifying as an expert witness. You're testifying to the facts that you observed, because that's what's been subpoenaed, your raw data, these numbers on a page. So now you're paid the munificent sum of, like in Louisiana, $8 a day and 8 cents a mile. And the case might go on for a month. Do you still feel the same way?
I firmly believe in what I published to be right.
What if it happened when you were in your first year of medical school?
It's still,
But if you're subpoenaed, you have to be there, right?
Yes. So how do you head off the subpoena? You don't give away the data. Now we're talking about the morality of not giving away the data. Jason was making the point that, gee, a right-thinking guy ought to give the data. And I was just arguing the other side. I mean, and if you'd have said don't give it, I would have argued the other side. I'm just trying to make the point, you see. I'm not saying it's the right thing or the wrong thing to do. I'm just trying to see that you see both sides of these issues. I mean, they have at least two sides. In many cases, more than two sides.
What about what's in the public's best interest? Aren't there other laws that say, well, this data is technically yours, but it could serve to benefit millions of people, therefore you cannot withhold it?
That's a great theoretical concept, but it has almost no application. It doesn't exist. It'd be roughly equivalent to a law which says that since he's got 3 cars and he's only one guy, the other 2 cars can be used by other people. From a procedural point of view, it'd be the same thing.
But what about, say you own some land, it's been in your county for 100 years, you pay your taxes, nothing wrong, and the government comes by one day and says, well, we're going to build an interstate through your yard, and we're going to buy your land, it's in the public's best interest to have this highway there, you have no choice in it.
Well, that's a good point. However, we're really talking about 2 different things. You're talking about the sovereign exercising its authority on behalf of the people to act in the public good. What I was talking about were private contests by individuals. I didn't have the government involved. I mean, it was a good shot, but it really doesn't answer the question. You really changed the hypothetical fundamentally when you pit it as private individual rights against the common good. What we've been talking about so far have been private rights, even corporations, individuals, private, non-governmental entities, no entity that purports to speak for the whole body politic.
So what's the use of your data if you don't defend it and stand behind it? Spending years of your life collecting this data and finally, oh, I don't want to release it.
I don't know but if I'm asked for advice about what somebody ought to do in the context that I just described, and I've seen what happens when you try to act for those reasons, when you adopt this personal, when you put your own sense of worth or value or your own sense of propriety on the line and say, geez, I'm a bad guy, or I'm a wrong guy, I'm not doing things right if I don't do this. When you do that, I think you go into the wrong direction. You make a myriad problems for yourself.
To add another scenario that you're painting here, I have a friend that's going right through it right now with the orthopedic companies and pedicle screws. And he did work back in, he was like a co-author on a paper, and he was like the third or fourth author, and they're bringing up that old paper. If you ever been authored on papers before, if you're third or fourth author, you've contributed some parts of the paper, but you didn't do the majority of the work. And he's being attacked from all sides on the data and everything along that line. And he's having to give up all his time and effort, and he's having to hire a lawyer, so he's going to be out of money just to represent himself, because it's getting too involved right now. And it's for that big lawsuit about using the bone screws in the pedicle region of the spine.
So that's a classic example of what I'm talking about. When you find yourself, if you're doing research and generating data, that in most cases you go through certain procedures and it goes into a journal, and by and large, although we sort of like to not pay too much attention to it, not too many people really care. Not too many people really care. On the other hand, one time out of a million, the data that you're generating might be pertinent to some big societal issue. Right? Then you find yourself being pulled around like a pawn, just like this pedicle screw situation. You might even generate that data before the issue of pedicle screws became as popular as it is now. I mean, it permeates orthopedics today. Really important issue. The guys who've written papers are now finding themselves being vulnerable. My advice would be to write the paper, publish the data, and get rid of it. They can't get what doesn't exist. These represent compromises, practical compromises with a real-world situation which didn't exist previously. This was not an issue before.
Would that be ethical to get rid of your data, though?
Could he get rid of his car? That'd be my view. I'm not saying that you've got to accept that as the definitive ethical judgment, but that'd be what I would do. Well, if it was my data, if I had, in her case, she did own it. She did it without a grant. It was her data. So I was trying to separate out all the legal issues before from the ethical issues I want to consider now. In this particular case, if she had got it from a grant, I'd have said, let's assume she got it on her own. In this case, no question, she did. And most of those pedicle screw papers were published without direct support from NIH. I mean, they're just orthopedic surgeons or people in medical schools just doing studies the way orthopedic surgeons do. They do biomechanical studies. Nobody paid for them. So what happens is that technically the data belongs to the institution. The institution allows it to be published. Now it's in the public domain. And so nobody owns it. Anybody can use it. But if you want to go beneath it and you want to see not just the mean and the standard deviation, which is printed in the journal, you want to see the exact numbers. That's the stuff that you might normally have in your notebook in your lab. And that's the stuff that they go after in a lawsuit. They're not going to settle for the mean and standard deviation in a lawsuit if it's a paper that's directly pivotal.
But along the same lines, if you, let's say you are a struggling postdoc student who has published something that would be in the domain, this would make you into someone who's not struggling.
Say that again?
If you were brought into a trial, and you had the data, and your data was proved to be correct, instead of being some lowly nobody doctor, you'd be somebody. Now, some postdoctoral students may look at it that way. You see what I'm saying?
You're saying it would be good? It would be good for the scientist's career?
Making their name through that trial.
Just the opposite is true. Just the opposite is true. A scientist is supposed to be somebody who collects data and is free of controversy. Now you're postulating a situation where this scientist is in the middle of this huge controversy. That's going to make it more difficult for you to get funded by NIH. It's going to make it more difficult for you to get promoted. Not better, worse. You're controversial. Why? Because what are 99 out of 100 people going to see? They're going to see the smoke and the sort of the flames and the controversy around the edges, and they're not going to take the trouble to get informed, and they're not going to recognize that you're really the Dudley Do-Right, and it's the other guy who's the malefactor in the case. They're not going to know that. They're just going to see all that smoke in the background that will have nothing to do with it. That's what in my career, 30 years of working around, that's exactly what's happened in every case I've ever seen. That's what's likely to happen. Controversy, by and large, is not good for you. If you're trying to make it in academics, if you're trying to make it as a grantee and trying to get funded and impress a study section that's going to review your proposal. Generally speaking, it ain't good. In the business area, suppose you got an NIH grant, suppose you got an NSF grant right after this cold fusion business developed, and it sounded really great to you, and you put a lot of effort and time into research following some hypothesis about cold fusion, and you came to the conclusion that it was really a fraud, nothing to it. I mean, you couldn't tell in the beginning, you did the experiment the right way, and now it all comes down to nothing. Well, you decide that maybe it's not a good idea for you to publish data that says there's nothing here, nothing works, and the data is negative. You know, there's a great prejudice in science against negative data. Sometimes negative data is important, but it's awful hard to get it because no journal editor wants it. There's some reasons, I guess, for it. There's some reasons why it's not the right posture or position for journal editors. Putting that aside, that is the fact of the matter. You find a negative study, you're going to find it hard to get it published. You have a negative study in cold fusion, decide you don't want to get it published because, after all, you spent all this effort and time looking into something and now there's nothing there. You just soon not advertise that to folks. Does somebody have, say, a business that's trying to decide whether, a venture capitalist trying to decide whether to invest in cold fusion? Sounds great. Unlimited power. He knows you got some data and he wants the data. Do you think he has a right to this data that you just generated? You personally might not want to see it disclosed. You'll be associated with these negative studies. If that is your attitude, do you think it's right that somebody should make you disclose it? What do you think? What do you think?
I was going to say, what about the situation where some people disclose their data before they've had a chance to repeat their experiments, such as the case in Utah, where those...
Yeah, Fleischmann opines. I know. That's the flip side of this coin. That's going too far, too fast. You know, that then represents that just represents a everyday run-of-the-mill violation of what proper scientific procedure is. I mean, depending on how it's done and how careless it is, it might be outright fraud. But that's another issue. What about my issue? There was no effect. You have all the data. And your frame of mind or your attitude, take this as part of the hypothetical, is you just assume not, you really don't want to talk about it a whole lot. It's just not good for your career. Do you have a responsibility, an ethical responsibility to disclose it to as a venture capital group that wants to see the data?
The university makes you.
The university won't make you. Why? All the university can do is proceed with patent application or give you the rights to do with it whether you will. That's the academic tradition in the United States. So we've hypothesized there's no financial value associated with it. So the university is out of the picture now. They're not going to do anything. It's between you and the venture capital group, and you're trying to do what's right. What's right?
You ought to put yourself in their position. If you were going to invest in companies, do you want to know all the pros and cons? And if you're like, no, I don't just know good stuff, well, that's your own thing. But if I was in a situation, I'd put myself in their position. If I'm going to invest in this company, I want to know what the positives and advantages, what are the possibilities of failure. I mean, there's a risk involved no matter what with the investment. But I think you're ethically...
So let me see if I understand your position. Your position is that I should give you the data that I generated, which I'm a little bit embarrassed about as part of the hypothetical. Just as I don't really want to disclose it, but so that you can make money, I should give it to you. Is that what you're saying?
Well, if I'm investing in...
No, not my company, your company. I've got no relationship to you. You have your own cold fusion company someplace. It's just that I have this data.
Yeah, okay, if we're working, if I'm putting my money into you to do this research.
Oh, no. That's different. Then it would be your data. Okay. I generated this using, I don't want to say NSF funds, because if I say NSF funds, you see, then the counter argument is going to be it belongs to everybody because it's taxpayer monies that paid for it, and that would be the correct answer. So I don't want to say NSF, but I also don't want to say I got the money from you. I got it from a third party, a private individual.
So I'm investing in something that you've done research in?
Correct.
Okay.
Correct.
If I've approached you and asked you for it.
Right, you have. And I said no. You think it's my obligation to give it to you?
Not if I'm not directly investing in you.
Right. Anybody disagree with that?
I don't think you have to.
Don't have to give it.
No, I mean, I think if you wanted to be ethical about it, but you stood, I mean, if you wanted to give this guy a recommendation and not disclose your data, I mean, you could say, based on the stuff that I've done,
right.
I recommend that
right.
you don't do this, but you don't necessarily have to give them all your information.
There'd be no, then what about this idea that, you know, what a scientist is supposed to do is generate data and make it available? I mean, you can see not making it available, there's a financial associated with it, but there's no financial aspect associated with it. What about this baseline default position that knowledge is supposed to be available for the benefit of all?
I think it should be.
You think it should be? Yeah. I would have to give it to him, even though...
I think it should be published. It's a little bit different as far as not being business-oriented, but for my dissertation project, I had to use 30-some animals, and of that, I only got like maybe 6 or 10 good animals that I could use in the study. If you go and look in the literature, everybody says only the good animals that they...
I know.
They didn't say that it took them 30 or 60
I know.
in order to be able to conduct the research.
I know, but the situation, okay, but the situation normally is that you can't get the negative stuff published. I mean, there's an overt bias on the part of journal editors about getting it published. And we're not talking now about publishing it. That would have been an easier thing, okay? I'm talking about making it available to him who's a venture capitalist. We're not publishing it. It's making it available. It's publishing it only in the general sense that I'm making it available to an individual as opposed to hiding it. But it's not going to benefit humanity. It's going to benefit him in his economic activities. It may, for example, lead him not to invest in cold fusion. So who benefits? He does. He saves some dollars.
I mean, you may go down the tubes while he's making money. It's not like you're saving anybody's life. You're just trying to...
Let me take away the, let me change the hypothetical a little bit. Suppose, it's political arena. Suppose you were, in your first incarnation, you were a scientist and you got an NIH grant. You remember this guy from Wisconsin who used to get these Golden Fleece Awards for research because he thought the research was silly, you know, Golden Fleece Award because the federal government supporting research on cockroaches or something like that, you know. Suppose you got one of these grants that he thought was silly. You did an experiment in your early incarnation in biology having to do with head lice, you know, and you collected this data. And now it's 20 years later and you're running for state senator. And the records are no longer available from NIH, which funded the study, because they only saved the records for 3 years. He wants the data from your head lice study. Why? Because he wants to have a negative ad campaign, and he wants the little lice crawling across the screen, and he's going to say, "Don't vote for Smith. Smith favors lice." I mean, he's going to do something. Do you have to make the data available?
Whose data is it?
This is NIH paid for the data. NIH paid for the data. Is there a responsibility to make it available? He can't get it from NIH anymore. You know, there was a time he could. There's a time he could. And NIH is very open about things. And in fact, every investigator that gets NIH or NSF money has got a promise to disclose the data, including the raw data, to people who have a bona fide interest.
If NIH or whoever it was destroyed it there 3 years past,
right.
It wouldn't be, if I'm running for office,
yeah.
it would be in my best interest to give them this life study that I did
yeah.
to smear me.
Right. Well, isn't that what we're talking about in every example? We're talking about what your best interest is versus the interests of other entities, something other than you, a corporation, individual, or the common good. That's what this is all about, isn't it? It's about what's good for you as an individual. It's one pole. The traditional practice in science, which is open disclosure, is the other pole, and what's good for some other third party. That's what all these things are all about. And my point is, none of them, they're all pertinent to where you folks are heading, and there ain't no easy answers to any of them. I mean, I do not want to convey with a few exceptions, I do not want to convey the attitude that there's a right or the wrong, or that I'm suggesting that one is right. Whatever you say, I'm just saying the opposite, just for the purpose of making the point that there's another side. I don't think there are any easy, and it gets worse. We're going to go on now, with one or two exceptions. This question of what's the right thing to do becomes more difficult, not easier. We've been dealing with only a small subsection of problems. Let me go on. Just a very brief word about patents. A patent is something that you get from the federal government if you invent something. Now, not if you have an idea, but if you have a new and useful process, machine, manufacture, a chemical, something concrete, not just a concept. You can't patent a concept. It's not the right to do anything. It's the right to prohibit somebody else from doing it. That's all it is for a certain period of time, 17 years. In general, you got to go get it yourself. If you're Dr. Napper or me, you got to go through the technology transfer folks at your institution. They decide whether they want to fund the lawyer or not. If not, it used to be that you used to be able to get an assignment and do it yourself. Now I'm having a hell of a tough time getting that done because of that prosaic problem I was telling you about before. One area where this patenting business is really becoming a heated issue, and I'll come back to it in a few moments, is this question of genes. Some people are actually trying to patent a gene. You take a segment along a DNA molecule, a certain series of bases, it codes for a protein, it's the genetic plan for a certain protein. Some people are making application to patent it. Hunks of the human genome, something that all humanity is heir to, the patent office is considering awarding patents. And in some European countries they have. In some other schemes, one does not go after the patent for the section of the genome, the section along the DNA, the gene. One goes after the protein that it codes for after demonstrating that that protein has a certain use. You know, the many sections of the genome that code for proteins, let us say we know it will make a protein because of the pattern of base pairs that we can see, but we don't know what the protein does. Don't know what the protein does. So people are trying to get patents for these proteins, betting they're going to turn out to be important. And since nature tends not to make too many things it doesn't need, chances are it is going to turn out to be something that's important. Now it's a race with the clock. Can you prove it's important and make a profit within the 17 years that you have the patent? There's a whole area of development which has exploded within the last few years. Nobody seems to know where it's going. No one seems to have thought through at all what the ethical ramifications of this are. Let me say a few words about animal studies. The chances are that some of you are going to be involved in using animals in research if you haven't already. This slide indicates the general use of animals in the United States. There are maybe 2,000, 2,200 or so places in the United States where animals are used for various kinds of experiments. The number of dogs that have been used have been dropping off precipitously. It's just politically become very difficult to work with dogs, irrespective of whether the dog is the appropriate animal model for which you're trying to develop. The number of primates has begun to drop, and you have got to have an awful lot of money, and you have got to have a justification beyond all belief in order to be able to rationalize experiments with primates today. That can be a serious problem for certain kinds of studies, but it's a political reality. They are rare, they are expensive, and people care about primates. Cats also. I haven't bothered listing rats and mice, and nobody really cares about them. They are just a little bit above cockroaches in terms of public esteem. So with the exception of some formalized rules I'll tell you about in a minute, there's been an enormous turning away from other species to rats and mice for the biological experiments that need to be done. 20 years ago, the question of whether you did animal research or not had to do with whether you had the money or not. There was no public concern. Certainly it wasn't in the early 70s. By the mid-70s, it started to become generated. There were a classic set of cases of people who abused animals, and there was a political movement that developed which regarded individuals who were opposed to use of animals on philosophical grounds, and they acquired, really, as I look at it, an extraordinary amount of clout in terms of what they were able to get done, because as a result of the public perception that something needed to be done, by the 70s, but certainly by the early 80s, we had a full-blown regulatory response that was put into place in the United States. It now affects virtually every institution, public and private, in which animal research is done today. It's almost impossible to publish a paper unless you've done it at an institution where the animal care facility has met certain standards. It's really fundamentally changed how animals are used. Some for the good and some not for the good. Just to give you a general idea of how the scheme works, because if you do animal studies any place, you will see it. The legal authority for it comes from the Department of Agriculture and from the Department of Health and Human Services, which NIH is. It's a strange combination, but what the feds were trying to do with their legislation is take care of all animals, whether the animals were in one of the 2,000 places where research was done, or whether the animals were in a circus or a farm. Didn't make any difference. They were trying to look out for all animals, all animal welfare. So you've got two kind of sets of regulations which come to bear. We're, of course, in science mostly concerned with this, although in the background this is important. The way the scheme works is that the NIH provide a series of rules which they essentially require each of the entities that do research, Louisiana Tech, the Midwest Research Institute, Battelle Research in Columbus, Ohio, or wherever, require them to sign an agreement promising to follow certain generalized rules. In return for that, then the federal money can be spent at your institution. The people who work at your institution get a grant. So that's the carrot and stick approach that they have. They generate the rules, and they force the institution that you work to adhere to the rules. Since you work for the institution, and these folks are making the institution enforce the rules against you. That's the way the scheme flows. And it flows down to you through a thing called an IACUC. And that's a term of art, Institutional Animal Care and Use Committee. It's the institutional organ that regulates you as an investigator in performing research. So wherever you are, there's an IACUC, and you got to go talk to the IACUC. You got to fill out the forms. You got to satisfy them before you can do anything that has to do with animals or animal research. That's the big picture about the scheme. That's the way it functions. What are the issues that are involved in this scheme? Before you can get permission to do an animal study, and here now we are talking more about rules that involve this thread, one of the four threads I told you about before when I first started, where the rules are relatively clear. I mean, what your personal attitude is, what you think, only determines whether or not you decide to go forward to study. If you do, you follow their rules. The rules are uniform, they're pervasive, and they're relatively clear. I'll give you an idea about some of the questions that arise, but this is an area where regulation, where this ethical issue has been largely taken out of the hands of the investigator and placed in the hands of a formal scheme. The first thing you'll have to do is you're going to have to justify that animals are needed. Before we get permission to do any animal study, I have to write a paragraph which explains why you can't do the study in cells. And I have to write a paragraph of why you can't do the study on a computer, mathematical modeling. Can't be done on a computer because the immune system doesn't exist in a computer. Can't be done in a cell because a cell is only part of the living organism, and it doesn't have a nervous system. I've got to write a rationale like that. That's part of the boilerplate. I've got to justify the species that's needed. I'm usually going to do a rat or a mouse. It might be a rabbit, sometimes a goat. God forbid if I have to want a dog, and I'm going to forget primates. I just can't get there. I can't afford it. And the scrutiny I'm going to get is going to be too great. And that's a common attitude among most investigators today, I think. Let me go back. The true core of these animal regulations is animal welfare. The name of the game is to not produce pain and suffering for the animals that are gratuitous, that are not part and parcel of the scientific data that you're trying to generate. If you're trying to develop a drug, for example, that relieves pain, you have to have animals that are in pain in order to determine whether it relieves pain or not. I mean, there's no way around that. However, there are many procedures which would have been done in the past, which would have been generated pain or discomfort for the animals, which can be avoided by taking certain steps and yet not prejudice the experiment. Those are the changes that the spirit of the law was devoted to. That's what it's trying to accomplish. In practice, from institution to institution, sometimes things get a little murky. At our institution, for example, there's a certain group of folks on the committee who are hot to criticize your science. So you go before them, you say, I want to do such and such, and there's going to be a guy in the committee who's going to say, well, gee, that's bad science. I wouldn't measure it that way. I'd measure it this way. Or I wouldn't put the screw in here. I'd put it in there. I wouldn't use this drug. I'd use that drug. This is a scientific issue which sort of gets melted into the animal welfare issue. And I've been on the committee a long time, and I'm always diligent about that kind of an issue. But there's several issues like that that sort of complicate the core notion, which is really what the public was concerned about in the first place. The consensus was not to prevent animal studies. The consensus was to minimize animal suffering. That's what these rules are really intended to address. But the rules do make certain bows in the direction of public perception. When I operate on a rat, I've got to sterilize the instruments, just like you were going to be operated on. They get the same degree of sterilization. Why? I operated on rats for 25 years, never once had a rat that got infected. Rats don't get infected. I mean, they live in filth. So if the instruments are clean, the chances of them getting infected are absolutely de minimis. It's not going to happen. Nevertheless, there's something kind of neat about somebody who takes a sterile pack and opens it up and it looks really cool. So now everybody who does animal surgery in the United States has got to have sterile instruments, irrespective of the science, whether it's needed or not. Nobody wants infected animals. If animals are getting infected, we would sterilize the instruments. We never did because we didn't have to. Now we do. Certain methods of euthanasia are sort of ugly. Cutting off a rat's head. It's kind of ugly. So now it's very difficult to do that. You know, there's certain studies where the animal's got to be killed very quickly before there's any neuroendocrine response. Because you're trying to measure something in the blood, the neuroendocrine system can kick in a few seconds. So you don't want, for example, the animal to go through CO2 suffocation, which is the classic way for killing small animals now. You want it to go from life to death that quickly, not in 10 or 20 seconds. But it looks ugly. So now it's very, very difficult to do because it looks ugly. You got to work very, very hard. Cervical dislocation of mice is another example. I mean, it looks ugly to grab a mouse's head. You can't do this on mice. You can do it on rats. You can't do it on rats. You can do it on mice. You grab the head, you pull the tail, you dislocate the spine at the cervical region, and the end comes immediately. It's very quick, it's very cheap, it's very safe, but it looks ugly. We can't do that anymore unless we work real hard to justify it. One of the interesting aspects about animal research and where it's going is it's ultimately going to force a kind of a refocus on what life is and what it means to say your own life. People are patenting life. Harvard has a patent on a mouse that has a propensity to develop cancer. This onco mouse. That is to say, they made a mouse. They incorporated a mouse into a fertilized egg. Excuse me. They incorporated a gene into this fertilized egg, and this gene confers a predilection, a likelihood of developing cancer. So now instead of the mice spontaneously developing cancer at the rate of 1 per 1,000 by the time it's 18 months old, maybe 20% of the mice will develop cancer by the time they're 6 months old. Tremendous animal model if you're doing cancer research. Harvard owns the mouse. Owns the mouse. And it's a little bit it's hard to know what it means. You know, if you own a horse, I mean, the horse is yours. I mean, the horse doesn't have rights. I mean, if you wanted to kill the horse, I mean, you could kill the horse. It's your horse. Is that the way? I mean, we're going to build this into law now. Is that the kind of society we want to have? And particularly as we start making mutants of animals that look more and more like us, which is what's happening. It's really, there are all kinds of committees are meeting, all kinds of dialogue. I don't know where this is going to go. But all I know is that the patent applications for these living entities are piling up at the patent office. So you're definitely going to hear more about it in the future. The bottom line is, as far as animal experiments are concerned, is animal experimentation and the ability to do it is considered a privilege. It's certainly a privilege within an academic setting. You follow the rules that society has laid out, or you don't do it. You say, well, I'm going to build my own institute and go home and take $1 million out of the bank and build my own place and have my own mice and do it my own way, and that's fine. You can still do that. You might not be able to do it 10 years from now. You can still do it now. But try and publish a paper. No chance. From data from that source. What time should I end? When?
Officially, they're scheduled till 5.
I won't keep you that long. I think about another 15 minutes, and then I'll. I wanted to tell you a little bit about human research because this. I don't know, those of you who go into medicine or biology in graduate school do some and be familiar with it, but I think most of you will hear about it in other ways. And since you're educated in science, you're likely to be people that will be approached by others who are not educated in science about these kinds of issues. So you should be familiar with the general framework for human experimentation. If you go back and you look at the medical literature in the 20s and 30s, you can find articles in which a doctor is operating on a woman for breast cancer and wants to know if this tumor would grow in another woman. So he takes some of the tumor from one woman and puts it in another woman, and then writes an article about whether or not it grew. And there are things like this in the literature in the 20s and 30s. Then, of course, in the 40s, you have the Nazi doctors and the experiments that they were doing. You're all familiar with those terrible things. And after World War II, the notion develops that the society needs some kind of rule to regulate human research, because there was nothing. So there was a set of protocols, these Nuremberg protocols they call them, which purported to set out in general terms what people could do to other people in the context of experiments. And not much happened throughout the 50s and the 60s. But in the 70s, there was an explosion in this country whose roots go all the way back to the 30s. In Alabama, the federal government, the Public Health Service, the folks at NIH who have all the money, decided that it would be really great to know what the natural history of syphilis was. Just follow folks and see what happens to them. So they began enrolling black farm workers from a county in Alabama with the full cooperation of all the medical establishments in that part of Alabama in a program. These guys thought they were getting treated for syphilis when in fact they were given no treatment, and the whole scheme was to see what happens to syphilis. Now back in the 30s there wasn't much of a treatment, so it wasn't much of a denial of anything. But then in the 40s penicillin is developed, and when there's now a treatment for syphilis. So what happens to the Tuskegee study? It goes right on. These guys are never told that in fact there's a treatment for this disease. The government follows them through the 50s, through the 60s, and into the early 70s. Syphilis is not a pleasant disease in its later stages by any stretch of the imagination. Treatment completely withheld. In 1972, the Washington Post has an article in mid-1972 disclosing this whole story. I mean, it was just really terrible. Within a year, we had federal legislation which regulated human research in this country. Everybody was shocked. They couldn't believe this was going on. The government didn't know anything about it. I mean, everybody was denying everything. So nobody was ultimately responsible. The guys who were in the study lost out. what society gained was a whole set of regulatory reforms, and this wasn't going to happen again. And so far as I can tell, nothing like it has happened again. So we now have a complete regulatory system for regulating human research in the United States. There are about 600 or 700 places where this takes place in the United States, and the scheme is the same every place. The rules come down from the Health and Human Services, one of the federal agencies. They go to the institution, one of these 600 or 700 institutions. The institution regulates a board, again a term of art, IRB, Institutional Review Board. It's the human equivalent of the IACUC. These are the folks who enforce, who take care that the federal rules from these folks are applied appropriately. They are the responsibility, they're the responsibility for enforcing these rules. And they deal directly with the investigator. If you want to do a human study, you go to the IRB at your institution, tell them what you want to do, why you want to do it, how you're going to do it, and they say yay or nay. That's the scheme in the United States today, followed virtually every place. At every institution, the particular rules are codified, written down in the document that each of these 600 or 700 institutions has signed with the federal government. So you can, wherever you are and you're going to involve in human research, you'll be given a copy of these rules. These are the rules that the IRB takes care that are enforced. What are the issues that arise in human research? Well, first of all, what exactly is human research? In other words, when is a physician, and we're almost always talking about a physician, because although we're going to have PhDs involved in studies, there's always a physician who is medically responsible. Every clinical study that I'm part of, there's some physician who's medically responsible, and he's usually the one who's going to deal directly with the patient involving certain things like informed consent. So what's the key thing that makes what a doctor is doing to a patient research as opposed to delivering ordinary clinical care? Anybody have any idea? I don't know if it's a fair question, but it's an important one. What makes what a doctor does research versus clinical care? What trips it? Anybody have any idea? That's close. Except that it's not there because many times what a physician will do is not generally accepted. It's just going to be something he thinks is appropriate under the circumstances. I mean, he won't even know whether it's generally accepted or not. Of course, he'll have available to him a certain set of drugs that he can prescribe, a certain set of procedures that he can do for certain classic signs and symptoms. But there will be many patients who walk in the front door that are not like any other patient who walked in his front door. So there won't be any well-defined accepted practice. So he's going to wing it. He's going to do what seems best to him. It's a good guess, but that's not it.
I'd say when you're not trying to help the patient, when you're basically on information.
That's it. That's the tripstone. You have to ask, when the physician is doing what he's doing, is he doing it because the main focus is to treat the patient, or is an important aspect of what he's doing the idea of collecting data for later scientific evaluation? Keep that in mind. That's an important distinction. That's what makes human research human research. Because I can guarantee you some things that I'll describe to you if I have time, or certain things you'll see in the future which will look like human research. I mean, you say, well, geez, it's researchy and it's human, therefore it's human research. It isn't. Why? Because the purpose is not to collect data, the primary purpose. The issues that typically arise, the classic ones, are the two I've sketched here. Informed consent. The really outrageous thing about the Tuskegee study was not that they withheld treatment. It's that they withheld treatment while not getting the consent of the people that were being handled that way. That's the egregious aspect of that behavior. That's what made it wrong. Why? You've got a right to do anything you want with your body. So if you don't want to be treated and you agree for whatever reason not to accept a certain medication, that's your prerogative. However, if there is a treatment and you're not told about the treatment and you're shunted down some other path, that's where the the egregious, wrong, pathological nature of that project came from. Folks did not consent to what was being done to them. The single most important aspect of a protocol when an IRB gets a proposal to do a human study is to determine whether what's to be done is adequately disclosed on these informed consent forms that are going to be given to the patient. Because if the patient is fully apprised, knows as much as is known and is conveyed to the patient in terms that are appropriate for the patient, that fulfills the investigator's responsibility. So the IRB's chief task is to make sure that those informed consent forms are accurately and adequately structured. Another aspect is the idea of conflict of interest. If a doctor's collecting tissue and he takes the tissue from the patient and then cultures the tissue and grows an immortalized cell, and this cell now becomes a useful reagent or product or diagnostic product, and there's money to be made, and he's doing this on the tissue that he's taken from the patient, or if he's counseling one form of treatment versus another form of treatment because it's in his interest. These are the classic kinds of violations of the applicable rules. These are where conflict of interest come into play. Let me briefly give you a few relatively straightforward hypotheticals regarding human research, and then I'm going to close with a few comments about tissue research, fetal tissue research, because the jury is still very much out on that. Suppose we have a situation where a doctor is given a drug to a patient, and the drug was approved for treating some other disease, and the investigator has strong evidence from a journal article that suggests that this drug will work for this patient's disease. And the investigator tells the patient, I'm going to give you this drug. I think this is a drug you ought to take. Not licensed or approved by FDA for this application, but the doctor has checked the literature, he knows about this area, and he thinks that the patient ought to take this drug for this situation, and he prescribes the drug. Is that... In your sense, would that violate proper rules for doing human experiments? Is that anything wrong with that? Or is that just good clinical care? The doctor doing the best he can?
Did you receive informed consent?
No. No. If the doctor's going to do that, he's going to have to say, this drug is not approved for this purpose. I think it's the best thing for you, but it's not approved for that purpose. I want to prescribe it for you. Okay? Patient says, yeah. Then it's okay. Otherwise, it's not. Another one. Investigator administers either 2 drugs to a patient, depending on whether it's an odd or an even numbered day. This happens an awful lot in medicine. In fact, most of the human experiment protocols in all the years I was on the IRB at our institution, at LSU, were of this design. Here's the design. The 2 drugs that are available for treating a patient with a certain disease. This one's approved for this disease, that one's approved for this disease. The doctor doesn't know which one's best. So what he does is he gives drug number 1 on odd number days and drug number 2 on even number days. That's all he does. They're both approved, and his procedure is simply to assign them that way. Does anything about that violate rules of human experimentation? Anybody? Is that all right?
I don't think so, as long as you don't know that one is better than the other.
What's human... Who was the one who defined human research for me? Wasn't it you? What was the definition of human research?
Well, you're not doing it for patients.
Right.
For the patient.
Right. Now ask ourselves, is the from an individual patient point of view, is the drug he's getting as opposed to the other drug, that decision being made for his benefit or for some other benefit, for some other good? Who benefits from this random assignment? Does the patient? Who's it being done for? Why is it being done?
patients that come after.
Say again?
The patients that come after.
Right, for the general societal good, because we want to answer the question of which drug is better. That's why it's being done, not being done for the good of this patient. So this patient then is being used for the purposes of collecting data and answering a question that goes beyond the patient, and it's being done without his consent. It's been very difficult for clinicians to recognize this distinction. They say, well, I could prescribe this drug or that drug, it's perfectly okay, but now if I do it, and I have no reason to prescribe this drug or that drug to this patient, that's what his argument will be. The counter-argument will be, actually, if you focus on individual patients, there probably is one reason or another to describe one drug or the other. I mean, after all, the second one got developed after the first one. There was some market share, there was some slice that the second drug was being aimed at. There is some patient-based consideration. That'll be the counter-argument. If the patient is being used to generate data, when the patient thinks that all the decisions are being made for him by the physician based on factors that relate directly to him, that's the presumption, that's the frame of reference, that's the default position. When a physician is making judgments about how a patient is to be treated, taking into consideration factors other than the things that directly relate to the patient, that relate to the common good, by definition, as far as the feds are concerned, this is human research. That's where we cross the line. That's where it becomes bad.
At what point would you not be doing that, though? In other words, everything that you give a patient is going to be recorded to some extent.
When you would not be doing it when you would not be doing it when you were not reviewing the data for the purposes of answering a scientific hypothesis. If the purpose is to generate data to answer questions, then you have essentially a prospective study. You're trying to collect data. You're going to analyze data at the end of a certain period of time. By definition, that's human research. I mean, the distinction is perhaps subtle, but it's absolutely clear. And most of the physicians are on the wrong side of it. They have a difficult time recognizing that. A surgeon says, I can fix a pain in the arm by two procedures. I can move the nerve from here to here, or I can take this part of the bone off. And which one I do is up to me. They're both standard treatments. They're both acceptable treatments, but I don't know which one is better. So I'm going to do one on one patient and one on the other patient in a series until I know. Fine. You better get permission from the Human Experimentation Committee before you do it.
What if he does pick one?
Means that one procedure is better than the other. So, say if you've been moving the nerve, and it's determined that removing the bone is better. All these patients are going to sue you now because they weren't getting the best possible care from you.
That can't happen any place in the United States, because the standard of care is always determined at the time the care was delivered. And in your hypothetical, there was no difference between those two treatments at the time the care was delivered, so there's no problem. Physicians don't get into a problem for doing that. They get into a problem for doing what they should do incorrectly. They shouldn't cut the aorta, and they do. Or they shouldn't put in pedicle screws, and they do. Unfortunately, they get into trouble for doing those sorts of things. Or they get into trouble when they conduct human experimentation without following the proper rules and something goes wrong. Because then you see, very often it doesn't matter whether or not the thing that went wrong was directly related to the violation of the rule. The whole case is sort of tainted. In the experiment that we were just talking about now, if the guy was doing a study and he didn't tell the patient and something went wrong, the patient is going to have a much better claim. He's going to be much more likely to be successful in the suit because this whole procedure was tainted from the beginning. There was no informed consent.
What if the doctor talked to the patient and say, well, we have two procedures here. Here, this one or this one. Choose whichever one you like. The patient says, well, it doesn't matter to me. Ask the doctor to choose whichever one he thinks is best. Would that be consent there?
It's informed consent. What is informed consent? You tell them everything you know, and they make the decision. It's very difficult for a physician to recognize. I mean, as a physician, it's 4 years of high school, 4 years of college, 4 years of medical school, 5 years of residency, and now you're treating somebody. I mean, you know a lot. You're a smart man. And there is this patient. The patient is ignorant, finished second grade, doesn't know anything. He's a laborer. I mean, he's an ignorant man. And it's very difficult for a physician to recognize that that ignorant individual has control over his own body and has got the right responsibility for making the final judgment. Not you, this knowledgeable sort of big shot who knows everything. This idea of recognizing what your space is, what your place is relative to the patient is a real fundamental notion, and it's hard when you're in the trenches, when you know a lot and he knows a little, it's hard not to cross that line and act as if you knew what was best for the patient. That's where we get into trouble. That's the sort of thing, when you follow down the line, you wind up with people doing the Tuskegee study of transplanting tumors. That's where the feds drew the line. We're going to recognize who has the responsibility to make the final decision. It's the patient. What's the doctor's responsibility? Get informed consent. Tell him everything you know. And tell him in language that he can understand. You know, at LSU, we were giving informed consent forms. We started off, we were writing them for people with high school education. And then it was a faculty member in one of the departments did a study and found out that the average reading comprehension level of the people that were taking part in these studies was at the 3rd grade level. Now, so we had the task of crafting informed consent forms, because the legal responsibility is to tell the patient what's there, what's involved, and in language that the patient can understand. And if you can't do it, the patient doesn't get involved in the study. You say, well, how do you get people in the study who aren't smart? You don't. How do you get people in the study who are in the emergency room and are not in a position to give informed consent? You don't. Under the rules. You can't get informed consent from them if they're in an extreme position. You can't get informed consent from them if you can't explain to them what's involved in the study.
What if giving informed consent would mess up the experiment? Such as, you want to see if there's a placebo and
it's a great question. What do you think the answer is? What do you think the feds say? What do you think the law says is the answer to that?
It's like a psychiatric evaluation. Isn't it right after they have an immediate debriefing? Right after, is that the way?
I think his hypothetical is clearer than that. I mean, you can't, he's postulating a situation where you can't do the study unless you keep quiet about certain aspect of the study. What's the rule? What do you think? Can't do it. Why? The alternative is for you to act as if you know what's best for that. It's for you to go too far down the road toward taking responsibility for somebody else's life and health. That's where they drew the rule. That's where they drew the line. And it's absolutely clear. I mean, there's no doubt about it. If you did that, you're in beaucoup trouble. Big trouble. So what does that mean? That means there's certain studies that can't be done. I was talking to at a scientific meeting 2 weeks ago, and a guy from FDA is talking about studies to develop drugs to treat women with osteoporosis. It's a very serious problem in postmenopausal women. How do you do that kind of a study? Well, somebody has a drug and a company, and they say this is good. They've done the animal studies, they think this is going to work. Now you're going to do a clinical study. So what are you going to do? You're going to randomize women of a certain kind to 2 arms of a study. One arm is going to get this new drug. What do we do with the other arm? Now keep in mind that there are approved drugs for osteoporosis on the market. Now, what you really want to know is what? Whether this new drug is better than the drug that's on the market, or whether this new drug is better than no drug at all. What's really the issue?
Better than other drugs.
Say again?
It's better than other drugs.
Okay, fine. Now, what if the other drug is on the market before the regulatory scheme came into play, so we don't know that that other drug is better than nothing? Now what? Now how do you design the study? I don't know what the answer is. The feds don't know what the answer is. That's why there's only 3 drugs on the market. They've both been on the market for a long time, and I don't see many other drugs like this coming on the market for a long time, because there's no clear scheme or procedure by which we can scientifically answer the question. What we really want to know is, starting from a woman's risk for osteoporosis, if you take this drug, does it improve things? Okay, if it does, then we'll do our next study by asking whether this new drug works better than this old drug. But if you already have a drug that's on the market that's never been demonstrated, what do you do? And let me tell you, this doesn't apply just to osteoporosis. Artificial hips, been on the market since Charnley invented them, I don't know, 25 years. Your hip goes bad, they put a new hip in. Your knee goes bad, they put in a new knee. All of these devices were approved before there was a federal device regulatory scheme. So the people who were making them didn't have to prove to the government satisfaction, FDA in particular, that these hips were better than some other kind of a treatment. So these hips are now on the market. Now if you come along with a new hip, new design, either it's the same as the hips that are on the market, or it's better. There are the two possibilities. If it's better than the ones on the market, since it comes along after we have this new regulatory scheme, it's got to go through what's called a PMA procedure, which is so incredibly difficult. No device has ever gone through it, and my prediction is no device will ever will. So, if it's a new device, forget it. Well, there's another way to get it on the market. You prove to the government it's exactly the same as the device that was made 20 years ago. Since that device has been grandfathered in, and your device is the same as that device, it would be illogical for you not be able to make the device when that company can make the device. So now you can make the device and sell it, and you don't have to worry about proving anything. That's the way every hip and every knee has gotten to the market. Our rules have worked ourselves into a corner, and given the law, given ethics, given science, there are in some cases, these are two, where it's difficult for me, and I've been living with these problems for a long time. I think I'm just as likely as anybody to see which way it's going to go, and I can't see which way it's going to go. I mean, every dimension, there's this big, thick cement wall. Reason for not going. Let me close very briefly by introducing you to this question of fetal tissue, because it is one of these human experimentation issues that is the cutting edge. I don't know what's going to happen. Just to fill you in, fetal tissue is cells obtained from aborted fetuses, and the fetuses are still undeveloped, and as a result, these cells are, and they're totipotent. They can become almost anything. As I say, they have the ability to differentiate into a lot of different pathways, and one of the pathways that they can differentiate to is to form neurons, which normally don't form in post-fetal life. So for Parkinson's disease is one example, but there are many other examples where certain kinds of nerves in the brain die. One of the touted treatments is taking fetal tissue and implanting it in the brain. And these cells then become neurons and replace the kinds of cells that died. Fetal research. Question is it okay? Is it a right thing to do? What do you think?
I think what they're trying to do right now is instead of counseling somebody that's considering abortion, saying, well, if you abort your fetus, you're I believe there's law now saying that they cannot inform any prospective mother that aborted a fetus of any possible future use of her fetus. It has to be an independent decision.
Right.
And once she makes that decision independently, then it's
Right.
free to use.
Right, right. In other words, there are some rules in place to avoid things like somebody getting pregnant so she can have an abortion, so that so she can sell the fetus to somebody, or so that the fetus can be used for her husband who has Parkinson's disease, or so that the obstetrician can make money. There are rules in place for that. I'm not talking about that. I'm talking about the propriety of using fetal tissue for this purpose. Is it ethically acceptable? Is it okay?
It's going to all boil back down to the abortion issue. For the most part, for aborted fetuses. If they decide abortion's illegal, then they're going to have to say that the fetal tissue from an aborted fetus for just people who just abort for voluntary abortions, then that should not be used for fetal tissue research. Then you get into the issues of what about naturally aborted fetuses?
Well, okay. Well, you don't get into that because naturally aborted fetuses are normally not aborted under sterile conditions, so the tissue isn't useful for this purpose. So we're basically talking about induced abortions as a practical matter, right? But I want to go back to your first point. Take away this illegal bit. That's another issue altogether. Let's assume that that's not limiting. Let's assume that's not limiting. What I'm asking is whether you think using fetal tissue from induced abortions is ethical, proper. Should we do it? Should we allow it?
Well, if it can help,
Go ahead.
if it can help other people and the fetuses are dead, yes.
All right. Who disagrees?
No, but I mean, definition of life is something that's growing. When that first cell is fertilized, it begins to grow. And you never got consent from that cell to use it. And that goes back to consent. But it's dead.
Uh,
Still don't understand how
You
you get
can't,
away
you
from
can't,
well,
if a person's dead, you cannot use their cadaver unless while they were alive and consent that you can.
What about a parent giving consent before their 10-year-old son or daughter to donate an organ
Yeah.
to somebody else?
that's where you get consent. So I don't want to make the, you really can't answer the question on a legalistic ground, like consent, for example, or not, because we have mechanisms for giving consent. I mean, if it's a legal thing, we can get around it. Underneath the legal thing is the ethical concern. That's what I'm talking about.
If you're talking ethical, I don't see how you get away from the abortion issue if you're talking fetal tissue research. And where does it come from?
It comes from an aborted fetus.
So if you disagree with abortion, how can you agree with fetal tissue research on an aborted fetus? That's a double standard in my opinion.
Well, let me give you a counter argument. If A murders B, C might profit, although he didn't agree with A murdering B. C might be B's heir, and he might inherit Whiteacre, and he's got this big, beautiful place. But he didn't want A to go out and murder B, but he can still benefit from it. He doesn't have to sanction the act. Why not the same thing here? I don't. I agree, maybe. Let's assume abortion is terrible, but it's been done. Okay, and there's the tissue. And the question now is whether it can be used. That's what I want to focus on.
Well, as long as the abortion is first of all legal, as long as it was independent, the decision to abort was independent of any decision, whatever the fetus is used afterwards, I think
It's ethically acceptable. Who disagrees?
I have to disagree because I have a hard time getting away from abortion. I strongly disagree with abortion. And I have a hard time
that
seeing
aside, as long as
Yeah, but I
is that what you're
can't
asking?
separate those two
All right.
personally, so
Let me.
withdraw.
Okay. Let me.
I can't
So.
separate the two. They're one.
So let me, in other words, your idea is that the initial obtaining of the tissue itself is so intrinsically wrong that it's not possible for any good to come out of it.
Well, no, I don't want to say that, but if you demonstrate a use for it, the likelihood of it becoming illegal diminishes.
But what happens if this fetus has been aborted under independent decision, and somebody else's life depends on that fetal material? You condemn that person to die because you don't think it's right to use that tissue?
If your dad's got Parkinson's, would you let it?
I wouldn't abort the fetus.
No,
How do you
the
trade off one
fetus
life
is
with
aborted.
the other?
Well, no, but it's
When you
done.
abort the fetus, you have no knowledge of what's going to be happening. You have no control what happens as far as research goes afterwards.
But right there, I don't abort the fetus.
Okay, that's your
I don't have
decision.
it.
You know, someone else does what
Someone
somebody
else
else does.
Yeah. I don't
The question presented to you is whether you will avail yourself of the right, or whether you think the initial act is so intrinsically evil you just don't.
I wouldn't use
But
it.
developing the use encourages.
Right, that's the point I'm getting at.
Right. Well, that's the counter argument. I mean, that's the point he's making. He's saying that if you follow their argument, you wind up with a system in which this tissue is available, because you've created a market for it in effect.
Right. So, personally, if like Dr. Chu was saying, that I think the use encourages abortion, well, I'm not going to use it because that's a double standard in my opinion.
Like he said, Dave said, if my father had Parkinson's disease, then my father would have Parkinson's disease. Because me, I believe so strongly that abortion is wrong. I believe any type of use that propagates that technique is wrong. And my father would
Those are
have
those.
So if they had that cure, you wouldn't,
Under somebody else, as long as it's legal.
if you had that cure, you wouldn't let him use
You
it.
just depends
Tell your
on.
dad.
My dad wouldn't. It goes back to your personal set of ethics. If your ethic says that you could kill a baby to save your father's life, then yeah.
Let me. Yeah, obviously we got two different points of view, right? And you can see how how fundamental they key in, and you can see the arguments on both sides. So you can see where it's related to some ethical outlooks and moral outlook on life, and where we're going to come down on this is difficult to say. There was a I'll just close to give you with one example, which actually took place in England, to give you an idea how this plays out. There was a school, a private school, a Catholic school in England, that refused to allow the students to be vaccinated against a certain disease because the vaccine had been developed, and it was the only source it was available from. The vaccine had been developed in cells that were obtained from aborted fetuses. So if that's your philosophical position, that's what you have to stand on, and you got to take what comes. That's like Jason says, if your father gets Parkinson's disease, you're willing to take what comes, and
Because
he would be, or you would if you're making a decision for him.
I think it's just a matter of what your beliefs are, how far you're going to stick with it.
Absolutely.
To what extent are you going to say, well, yeah, okay, enough. It's a big person.
Anybody have any questions about anything I said? Okay, great being here. Thanks.